So we are going to find the relative extremas using the second derivative test. Now we could use the first derivative test. We could use the second derivative test. We're using the second derivative test. So guess what? To do this, we're going to find the second derivative. So that's the first thing you're going to do, is go towards the second derivative. But don't you have to first get the first derivative? And to find relative extremas, don't we have to find critical numbers at the first derivative? So we pause at the first derivative, and we're going to find our critical numbers. And then we're going to go to the second derivative and do something else. So let's see how this all pans out. Here we go. Let's take the first derivative of this so we could get our critical numbers. So our first derivative, well, is equal to, the negative 2 stays in front. All right. The cosine of x plus pi is a chain rule, but it's a chain rule with nothing really happening. Here's why. Think about this for a second. The derivative of cosine is what? Negative sine, correct? And don't we leave the inside? Got it? But what's the derivative of this right here? The inside. It looks like it might be something, but it's just 1. So do I need to put a 1 out here? No. Now if that was a 2x right there, would you have a 2 on the outside? Yes. But since it's an x plus pi, there is no chain rule effect. So really you had to do chain rule, but it was 1. Okay, so it didn't really do much. And then what is the derivative of negative 1? 0. So we're done. Let's clean it up a little bit. The interval is because it would go on forever, so we kind of want to stop in that interval for this problem. So let's clean this up a little bit. So my first derivative is going to be a negative times a negative is a positive 2 sine x plus pi. So that is my first derivative. I am going to go to my second derivative, but let's pause and find our critical numbers right now. Since we're here, we could do our second derivative right now, but let's first find our critical numbers. So what we're going to do here is we're going to find when this equals 0 or undefined on this interval. So here we go. Let's set it equal to 0. So 0 equals 2 sine x plus pi. Okay. Now, does a 2 matter when we're solving it? No. You could divide both sides by 2 and kind of get rid of it. So we're really focusing right here. So when is sine x plus pi equaling 0? That might be a little confusing with this x plus pi. Can I use that u idea for this one? I'm going to just make it a little bit cleaner. Some of you could totally see when sine x plus pi equals 0, you can see it in your head. But I'm going to make it a little bit different. So what I'm going to do here is I'm going to do 0 equals, I want to know, sine u. And u is going to be x plus pi. So that is going to be u. So when is sine of u equal to 0? What would u be? Well, when is sine 0? That is at 0, correct? Pi, 2 pi, dot, dot, dot. Correct? But that's u. So can I convert this over here to x? Can I minus the pi over? So minus the pi over. So what this is saying, isn't x going to be u minus pi? So we're going to take away pi from every u value I have so far. And from there, can we convert this to x? Okay, let's convert that to x. So we're going to take every u and minus pi. So for x here, x is going to be 0 minus pi, pi minus pi, 2 pi minus pi, dot, dot, dot. Can you see a pattern? Can you start seeing? I don't want all these because some of these are out of my interval, aren't they? Yeah, because isn't this negative pi? So what x values do I run into here? That's out of my interval. What's pi minus pi? Isn't that 0? But is 0 out of my interval? It's an open interval. Is 0 out of my interval? Yes. So that's out of my interval. This was negative pi, just so you saw it. That's 0. What's 2 pi minus pi? Isn't that pi? Pi is in my interval. Can I keep going? Can you see the pattern? I'm going by pi's here. So what would be the next one in the pattern would be 2 pi? Is 2 pi in the interval? Yes. And this next one would be 3 pi, but 3 pi is on the edge. So these are my critical numbers. These are my critical numbers. It's not the answer. These are my critical numbers on the interval. So my critical numbers are where I might have a relative extrema. So all I care about are these two numbers. Just these two. Pi is a number. 2 pi is a number. And I know people struggle. It is a number. It's just a irrational number. So we're going to find, using second derivative, what kind of extremas these might be, or are they not. So we have our critical numbers. We now need to do this second derivative test. So I need my second derivative. So let's go back to this and do a second derivative. So what we have for a second derivative, we leave the 2, and the derivative of sine x plus pi, well, the derivative of sine, the outside, is going to be cosine. And we leave the inside. Now, what's the derivative for chain rule purposes of the inside? Well, last time, wasn't that 1? Isn't x plus pi the derivative of that 1? Could I put a 1 out here? Yeah, but it's kind of pointless. It's your call. So this right here is simply my second derivative. And what do we do with the second derivative test? We simply plug our critical numbers into the second derivative and see what kind of concavity we have, and that will tell us what kind of extrema these are. Let's do that. So we're going to do f double prime. Its key is double prime. We're doing the second derivative test. And we're going to plug in my first critical number, pi. So that would be 2 cosine pi plus pi. Let's see what we get here. When we do that, we get, let's see, that would be, we plug in pi, looks like we have 2, there should be another parenthesis there. I put a parenthesis there that didn't need to be, it's kind of interesting. I'm going to kind of get rid of that and just put cosine, pi plus pi, isn't that 2 pi? And cosine 2 pi, unit circle, that is 1. And what is 2 times 1? Do I even care about the value? Aren't I looking if it's just positive or negative? That's what's nice. You actually don't even care about the value. This is a positive value, so we know it's going to be happy. So that critical number right here, since it's happy, because it's positive, since this is positive, it's happy, what do we know about that value right there? It's a relative min. Now the problem is we have to go back and get the coordinate. We'll come back and get the coordinate in a second. But we know right here, this will be a relative min, correct? By that dot right there, it looks like a relative min. We will come back to it. Now let's find 2 pi. F double prime 2 pi. Let's see what we get here. 2 cosine 2 pi plus pi. Let's see, what do we get when we do that? Won't that become a 3 pi right there? Cosine 3 pi be 2 times, what is cosine 3 pi? Sorry, I'm not rewriting this. Hopefully you can see that's cosine 3 pi. Cosine 3 pi, isn't that negative 1? So won't that be a negative 1? Won't cosine 3 pi be negative 1? And so what's 2 times negative 1? Isn't that negative 2? So isn't that telling us it's frowning? So what does that mean about this critical number? It's a relative max. So I now know at pi I have a min, and at 2 pi I have a max. But now I got to find the coordinate. Usually you want coordinates of relative maxes and mins. So I know I have a relative minimum at pi comma something. We'll figure that out. And I know I have a relative max here at 2 pi comma something. We've got to figure out the coordinate now. So how do we get the coordinate? Be very careful. What function are we going to plug it into? The original. We have to go back to the original now. You have 3 different derivatives. You have a first derivative, second derivative, and the original. You got to be careful. very careful which one you plug it in. So we are now going to go back and find f of pi and f of 2 pi and find its value. So f of pi, we're going to put pi right there. So that's going to be negative 2 cosine of pi plus pi, which that'll be a 2 pi, minus 1. So cosine 2 pi is 1 times negative 2 is negative 2 minus 1 is be negative 2 times 1 minus 1. Can you tell that's negative 3? So I got a coordinate right there. By the way, this will be our answer. I'm going to box it right now. Next one is negative 2 cosine 2 pi plus pi minus 1. This will be a 3 pi. So 3 pi was negative 1. So won't that be negative 2 times negative 1 minus 1? Which is positive 2 minus 1, which is 1. There's my coordinate. So relative min is here, relative max is here. We did the second derivative test to tell concavity at the critical numbers, and we now know. Now, could I go back and make a table and find first derivative test and check both sides of pi and 2 pi and use first derivative to tell if it was a relative max or min? Totally. But we use second derivative test. And to find coordinates, we always go back to the original function. Be careful with that. Coordinates are original. First derivatives are slopes. Second derivatives are concavity. Let me say that one more time. First function, the original function is always coordinates. First derivatives is slopes. Second derivatives is concavity. It's important to know when you plug numbers in, that's what it's finding.